So now in this video, we're going to take the LM334. It's an adjustable current source. And so looking at the flat side, we have the V plus pin right there, the R pin right there, middle pin, and the V minus pin, the pin on the right. And to control the current through here, use a resistor. This video, we're going to use a light dependent resistor. So the value of resistance is going to change based on how much light is on it. If we make it dark enough, this has pretty much infinite resistance, and if it's bright enough, it has practically no resistance. And so one thing I want to do is make sure that we don't exceed probably about 8 milliamps of current. And so this is a 2200 ohm resistor. We're going to be using an 18 volt power supply. And the voltage really doesn't matter. The lower voltage, the better actually. But in any case, there's a wide range of voltages you can use, and I've been using 18 volts lately. So we're going to set that to the V plus pin right there. And the board kind of wants to be right there based on what is dangling off of it. So let's zoom back here, and first let's get a voltage reading. The power supply is off, so let's turn that on and verify that we are dealing with 18 volts at this component right now. There we go. So it's not finished being wired yet. So we're going to set the meter to measure milliamps of current right there. And so the probes, I'm going to be changing light levels and stuff, so I want to keep my hands free. So I have the probes here and my jumpers that are alligator clips that are crimped onto jumper wires. We just plug them right there, and then we can plug the wire into the board. Really easy. Keep my hands free. So we need to complete the circuit now. So the red jumper, let's put it back here so we can see things a little easier. That is going to where the V minus pin for the LM334 and one of the leads of the light dependent resistor right there. And then this jumper, we're going to go to the negative rail. That will complete the circuit, and you're going to see current flow. So right there, we got about 0.10 milliamps of current. If I turn the light down, you can see the current dropped way down. And so there's lowest setting, medium setting, and brightest setting. For this lamp, I'm going to grab my headlamp and get real close to it. And so it looks like we're getting about 0.9 milliamps of current. And I think I need to recharge this soon. And so about 0.9 milliamps of current. So now let's get rid of the resistor, because as I said before, it will limit current to about 8 milliamps of current, and at least with this light brightness we don't have to worry about getting anywhere near 8 milliamps of current. So I yanked that, we lost power, and so now I'm going to just replace it with a jumper to the positive rail right there. And it was not limiting current at all. It was absorbing some of the power though. It was helping to keep the component, the LM334, from getting too hot. It was helping, so it was absorbing some of the power. So there you can see we're back to the V plus, and there we go. The lamp at the brightest setting, we got 0.1 milliamps of current as we did before. And so the resistor did not affect the current flowing through it at all, just absorbed some of the power. And if it would have gotten closer to 8 milliamps of current, finally it would have came into effect. And there you can see with the lamp, again, we have about the same amount of current. So the resistor was not affecting the current at all. It was the adjustable current source, LM334. So that's it for this demonstration video. You can do a lot of interesting stuff with just a few components and a multimeter and some other things. And so I'm trying to put together a number of videos where I show that. So thanks for watching. I will see you in the next video.